Hello viewers, this program is concerned with the study of programming language paradigms, that is the various systems of ideas that have been used to guide the design of programming languages. These paradigms are realized to a greater or lesser extent in various computer languages, although the design of a given language may reflect the influence of more than one paradigm. Before we proceed to programming paradigms, first we will look at the meaning of the word paradigm. The word appears in the American Heritage Dictionary of English Language, 3rd edition, as an example that serves as pattern or model. Another and slightly more complicated explanation stems from the Merriam-Webster's Collegiate Dictionary, which says paradigm as a philosophical and theoretical framework of a scientific school or discipline within which theories, laws and generalizations and the experiments performed in the support of them are formulated. We can say that a programming paradigm is an approach to solving programming problems. There are few interrelated concepts such as programming technique, programming styles and programming culture, which tend to confuse many of us. The programming paradigm is a pattern that serves as a school of thoughts for programming of computers. The programming technique is related to an algorithmic idea for solving a particular class of problems. For example, divide and conquer and program development by a stepwise refinement. The programming style is the way we express ourselves in a computer program. It is related to elegance or lack of elegance. The programming culture is the totality of programming behavior, which often is tightly related to a family of programming languages. We will now enumerate the 4 main programming paradigms. It may be very well matter of taste if some of the additional programming paradigms should be considered as main programming paradigm as well. In concept definition, we can characterize a main programming paradigm in terms of an idea and a basic discipline. A main programming paradigm stems an idea within some basic discipline which is relevant for performing computations. The 4 main programming paradigms are imperative paradigm. In this paradigm, the language provides statements such as assignment statements which explicitly change the state of the memory of the computer. Second is functional paradigm. In this paradigm, we express computations as the evaluation of mathematical functions. Third, logic paradigm. In this paradigm, we express computation exclusively in terms of mathematical logic. Fourth is object oriented paradigm. In this, we associate behavior with data structures called objects, which belongs to classes which are usually structured into a hierarchy. These paradigms were developed to cope up with the important issue of enabling an efficient transformation of algorithms and concepts into code. As the main contribution of this exposition, we attempt to trace the basic discipline and the idea behind each of the main programming paradigm. First type of programming paradigm is the imperative programming paradigm. This works on the basic discipline and idea of first do this, next do that. The first do this, next do that is a short phrase which really in a nutshell describes the spirit of imperative paradigm. The language which reflects this paradigm recognizes the fact that computers have reusable memory that can change state. So, they are characterized by statements which affect the state of machine. For example, x equals x plus 1. This can only be understood mathematically by associating a sequence of values with x, let us say x1, x2, xt, where xt denotes the value of the variable x has at some time t. Thus, the above statement can be translated into mathematics as xt plus 1 is equal to xt plus 1. The phrase also reflects that the order of the commands is important. first do that, then do this would be different from first do this, then do that. Imperative programming paradigm is closer to machine representation. Classical languages such as C use a straightforward monomorphic programming style based on imperative programming paradigm. Monomorphic programming style is a programming style which supports only a single data type. In the field of scientific computing, only one and two dimensional data structures were initially used to develop applications due to limitations of computer resources. The imperative programming paradigm was sufficient for this type of task. Code which is developed this way supports only single data type and cannot be reused at all. Coming on to the advantages of imperative paradigm. First advantage is it is efficient. It is efficient because of low memory utilization. Second is it is more closer to machine. Third, it is popular and familiar to the computer programmers. The disadvantages of imperative programming paradigm are: first, the semantics of the program can be complex to understood or prove as a referential transparency does not hold. Second is debugging is harder. Third is abstraction is more limited than the other paradigms. Fourth is order of the statement is crucial, which does not always suit itself to problem. A subtype of imperative programming paradigm is the procedure paradigm. It is based upon the concept of procedure calls, in which statements are structured into procedures, also known as subroutines or functions. Second type of programming paradigm is functional paradigm. The functional paradigm works on the idea and discipline of evaluate an expression and use the resulting value for something. Functional programming is a simpler and more clean programming paradigm than the imperative. The reason is that the functional paradigm originates from a purely mathematical discipline, that is the theory of functions. In this paradigm, we emphasize the idea of computation as being about evaluating mathematical functions combined to expressions. The functional paradigm was explicitly created to support a pure functional approach to problem solving. We can characterize the overall properties of functional paradigm. First is the discipline and idea behind functional paradigm. It works on purely mathematical discipline and the theory of functions. Second is the value produced are non-mutable, that is, it is impossible to change any constituent of a composite value. As a remedy of this, it is possible to create a revised copy of a composite value. Third is it is atemporal. Time only plays a minor role compared to imperative paradigm. Fourth is it is applicative, that is, all the computations are done by applying or calling the functions. Fifth is functions are first class values, that is, functions are full fledged data just like numbers, lists, etc. Coming on to the advantages of functional paradigm. First advantage is it contains small and clean syntax. Second, it supports for reasoning about programs better. Third, they allow functions to be treated as any other data values. Fourth, it supports programming at a relatively higher level than the imperative languages. Coming on to the disadvantages of functional programming paradigms. First is it has been difficult to design languages under the functional paradigm, which produces programs which run as fast as under the imperative paradigm. Second is it is difficult of doing input and output operations. Third, functional languages use more storage space than their imperative cousins. The third type of programming paradigm is logic paradigm. The logic paradigm is dramatically different from other three main programming paradigms. The logic paradigm fits extremely well when applied in problem domains that deal with the extraction of knowledge from basic facts and relations. The logic paradigm works on the idea and discipline of answer a question via search for a solution. The logic paradigm focus on predicate logic, in which the basic concepts is the relation. Logic languages are useful for expressing problems which is not obvious what the function should be. Thus, for example, where people are concerned, it is natural to use relations. For example, consider the uncle relation. A given person can have many uncles and another person can be uncle to many nieces and nephews. Let us consider now how we can define the brother relation in terms of simpler relations and properties like father, mother, male, etc. Using the prologue, one can say brother xy, that is, x is brother of y. There are two people f and m, for which father f comma x, that is, f is father of x, father f comma y, that is, f is father of y also, mother m x, that is, m is mother of x, and mother m comma y, that is, m is mother of y. Last is male x, that is, x is male. We briefly characterize the main properties of logic programming paradigm. First is, the logic programming paradigm is based on axioms, inference rules and queries. Second is, program execution becomes a systematic search in a set of facts, making use of a set of inference rules. An example of logic programming is prologue. Coming on to the advantages of logic programming paradigm. First, it shows a good support for reasoning about programs. Second, the system solves the problem, so the programming steps themselves are kept to a minimum. Third, it can lead to concise solutions to problems. The disadvantages of logic paradigm are: first, the execution of the program is slow. It shows limited view of world. That means the system does not show about facts that are not its predicates and rule of inferences. The logic programming finds difficulties in understanding and debugging large logic programs. The fourth type of programming paradigm is object oriented paradigm. The object oriented paradigm has gained great popularity in recent decade. The object oriented paradigm works on the idea and discipline of sending messages between objects to simulate the temporal evaluation of a set of real world phenomena. The object oriented paradigm, often written as OO, focuses on the object that a program is representing and allowing them to exhibit behavior. This is contrasted with the typical approach in the imperative paradigm, in which one typically thinks of operating on data with procedure. In the imperative paradigm, typically the data are passive, the procedure are active. In the object oriented paradigm, data is combined with procedure to give objects which are thereby rendered active. For example, in the imperative paradigm, one would write a procedure which prints the various kinds of object in the program. In object oriented paradigm, each object has a print method and you can tell an object to print itself. Objects belong to classes. Typically, all objects in a given class will have the same kind of behavior. Classes are usually arranged in some kind of class hierarchy. This hierarchy can be thought of as representing a kind of relation. For example, a computational model of a university might need a class person to represent the various people who make up the university. A subclass of the person might be a student. Students are kind of person. Another subclass might be professor. Both students and professor can exhibit the same kinds of behavior, since they are both people. They both eat, drink and sleep. But There are kinds of behavior that are distinctive. Professor pontificate, for example. After discussing all the paradigms, the question arises that which is the best paradigm? The most accurate answer is that there is no best paradigm. No single paradigm will fit all problems well. The programmers use a combination of the models represented by these paradigms. Languages with features from different paradigms are often too complex, so the search of ultimate programming language continues. This ends the overview of the 4 main programming paradigms. From now on, the main focus will be on object oriented programming in C++ with special emphasis on example drawn from the domain of application program development. Thank you.